Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this word problem using the concepts of polynomial equation. As per the problem, a steel beam is supported by two vertical walls. When a 1000 kg weight is placed on the beam x meters from one end, the vertical deflection d in meters can be calculated using drx equals 0.0005 times x to the power 4 minus 16x cubed plus 512x. How far from the end of the beam should the weight be placed for a deflection of 0 meter? So we are given a polynomial function for deflection and we have to find the x value for which the deflection will be equal to 0. In this equation, x represents the distance at which a 1000 kg weight is placed from one end of the beam. We have to find the value of x for which d is equal to 0. So the first step is to sub in drx as 0 on the left side of the equation. We have to solve this equation. The first step is to do common factoring. We can factor out an x from the three terms in the parentheses. Next, we should use rational roots theorem to factor the cubic polynomial in the parentheses. The leading coefficient for this cubic polynomial is 1. There is an invisible 1 with x cubed. The number term in this cubic polynomial is 512. We should find the factors for the number term 512. Its factors are plus minus 1, plus minus 2, plus minus 4, plus minus 8, and so on. Since the leading coefficient for this cubic polynomial is 1, these factors of 512 represent the possible x values for which the value of the cubic polynomial in the parentheses is equal to 0. We have to sub in these x values one by one in the cubic polynomial to find out which of these x values make the cubic polynomial equal to 0. We can start with plus 1, then minus 1, and then go down the list. The x value that will make the value of this cubic polynomial equal to 0 is 8. That means x minus 8 is a factor of this cubic polynomial. Next, we have to use polynomial division to find other factors for this cubic polynomial in the parentheses. We should divide the cubic polynomial by the factor x minus 8. We can use polynomial long division or synthetic division. I will use synthetic division in this video because it's faster. The first step is to write out the coefficients of x terms in the cubic polynomial and the number term. In this cubic polynomial, there is no x term, so we'll use the coefficient 0 for the x term. We can write the value of x from the factor on the left side. Now we can start the synthetic division. We start by bringing the 1 down. 8 times 1 is 8. Negative 16 plus 8 is negative 8. 8 times negative 8 is negative 64. 0 plus negative 64 is negative 64. 8 times negative 64 is negative 512. 512 plus negative 512 is equal to 0. This last number represents the remainder for the polynomial division. It is equal to 0. That proves that x minus 8 is a factor of the cubic polynomial. The degree of the cubic polynomial is 3. The degree of the factor is 1. So the degree of the quotient from the polynomial division should be equal to 3 minus 1, which is equal to 2. So we should assign x squared to the first number 1, x to the second number negative 8, and negative 64 is the number term in the quotient. So we can rewrite our equation as in this equation, we have a quadratic expression in the second parentheses. We cannot factor this quadratic expression. Now we can analyze the cases that we get from the factors. The first solution is x equals 0. The second solution is x equals 8. We have to use quadratic formula to solve this equation. In this equation, a is equal to 1, b is equal to negative 8, and c is equal to negative 64. Square root of 320 is equal to 17.89. Now we can analyze the two cases, the plus and the minus. 8 plus 17.89 is equal to 25.89. This is the first x value. This is the second x value. So in total, we got 4x values from the equation. As per the problem, x represents the distance from one end of the beam. X cannot be a negative value. Therefore, negative 4.945 is an invalid answer. Therefore, there are three valid solutions for the equation x equals 0, x equals 8, and 12.945. And the unit is meters. Therefore, the weight should be placed at a distance of 0 meter or 8 meter or 12.945 meter for deflection of 0 meter. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.